Today our topic is AC bridges, and the first topic is Maxwell inductance bridge. So whatever we see Maxwell inductance bridge, it is there is a point B, it is connected to a detector, their point is D, there the point A and B is connected, there is a resistance, this resistance is R1, it is connected to a inductance, this inductance is denoted by L1, the current through A to B is I1, then A to D there is a resistance R2 and it is connected to a inductance, this inductance is L2 and resistance R2 here, R2, and between A and C, B and C there is a resistance R3, current through is I1, and for C to D there is a resistance R4 and current is I2. We know that the cell Maxwell inductance B is comparison very well standard resistance inductance. The connection is the for a bridge the balance condition there the detector voltage drop is 0, no current through B and D detector, so the voltage AB is equal to A and D, and voltage drop between B and C equal to C and D. So from that we know that impedance Z1 means A and B impedance Z1, and between D and C the impedance Z4 equal to Z2 and Z3 for balance in the bridge. This is the general condition. So for Z1 we know that Z1 here we get R1, there is a resistance L1, so R1 plus j omega L1, and R4 we represent by Z4, so R1 and Z2 we represent by R2 plus small resistance j omega L2 and Z3. So how we calculate, and here is R4 and here is R3. So how we calculate, we get R1 R4 plus j omega L1 R4 equal to R2 R3 plus R2 R3 plus j omega L2 R3. Then comparing the imaginary and real part we get R1 R4 equal to R2 R3 plus R2 R3. So if we take the unknown resistance R1 equal to R3, take common R2 plus R2 divided by R4, and imaginary part, if we take imaginary part, so J1 L1 R4 equal to J omega L2 R3. So from that j omega L1 R4 is equal to R3 into L2, so L1 equal to unknown resistance R3 by R4 into L2. So this is the two equation. If we draw the phasor diagram, so I and I1 current, the I1 R1 is the same phase, so we draw I1 R1 in this direction, and I1 J leading 90 degree inductance, so we denote this is IJ I1 omega L1 equal to I2 omega L2, voltage E1 and into. So if we draw the resultant voltage E, this is the resultant voltage E, it is E1, and for E3 E4 this is the E3 E4 voltage. So resultant E is denoted by that one. So Next is Maxwell inductance capacitance bridge. Maxwell inductance capacitance bridge. Whatever we see in Maxwell inductance capacitance, inductance is measured with comparison to a variable resistance. So what are the diagram for Maxwell inductance capacitance bridge? Same as Maxwell, there is just few difference here. The point A, C, B, D. So between A and D there is a detector, same as previous. A and B there is a resistance R1 and a inductance L1. Current here is I1. B and C there is a resistance. This resistance is R3. Here there is a capacitance. Capacitance is connected to a resistance R4. The capacitance is denoted by C4, variable capacitance, and between here there is a resistance R2. So suppose here I2 current is passing, so I2 current goes in this direction, the voltage same as previous case. So if we take the general condition for Z1 Z4 equal to Z2 Z3, same as bridge condition. Say here Z1 we get R1 plus J omega L1 with R4, and C4 is parallel, so R4 J omega C4 by 1 plus R4 by J omega C4, R1 R2 R1 plus R2. Z2 Z3 we get R2 and R3. So if we calculate this, we get R1 equal to what we get, R1 plus J omega L1 Z4 R2 R3 means R4 into J omega C4, R2 R3, 1 plus J omega R4, 1 plus J omega C4. So we get 1 plus J omega C4 is cancelled, so R4 by 1 plus J omega C4 R4 is equal to R2 R3. If we separated the real and imaginary part, real part and imaginary part, so we get R1 equal to R2 R3 by R4, and real imaginary part from L1 equal to R2 R3 by C4. So if we take the Q factor Q equal to W L1 by R1, we get W L1 at R2 R3 by C4 L1, the equation by R1. So we get, this is R1, we get the R1 equal to R2 R3 by R4, so R2 R3 by R4, so we get omega C4 R4. So advantage of the bridge, is the equation, two independent, there is no frequency, the L1 equation and R4 equation, and but the Maxwell is useful for measuring wide range of inductance power and odd efficiency. But disadvantage, it is the low, limited for low Q12, means one Q12 value is 1 to 10. In between it will be measured, but if has more than Q, then it will the disadvantage. So this disadvantage we can eliminate by Hayes bridge. So how we draw the Hayes bridge? Hayes bridge, here the same as Maxwell inductance bridge, but the here the resistance capacitance is parallel. So if we draw, here is the R1 and here is the L1. Here the detector D, there is a resistance R2, and between A, C and D, here previous case there is series resistance, here is the parallel resistance, so C4, and here is the R3. So again we take the equation, here the voltage E2, here E4, between C and 4A, and between this is E2, and here is the E1. So if we take for general equation, we that R1 plus j omega L1, and here we get R4 series with means 1 by j omega c1 r4 equal to r2 r3. Again we calculate the imaginary and real part. R1 r4 plus j omega l1 r4 equal to r1 by j omega c1 r4 by l1 by c1 r4 equal to R2 R3 R1 R4 plus L1 by L1 by C4 equal to J omega L1 R1 by R2. So from the real equation, real part or imaginary part we separate. So R1 R4 plus L1 by C4 equal to R2 R3, and the real part, and the imaginary part we get j omega L1 R4 equal to minus of 1 by j omega C1 R4. From that point we calculate the value of R1 R2 L1 and R3. How we calculate this? From that one L1 we get, from that point we calculate L1 is equal to R1 by omega square R4 C4, and so L2 I we get from the equation, and j square omega c 4 equal to, so we get the equation of L1. L1 we get here from j square omega L1 equal to R1 by omega square R4 C4, and if we put the L1 value here we get the value of R1 equal to omega square R2 R3 R4 C4 square by 1 plus omega square C4 square R4 square. So if we calculate Q equal to W L1 by R1, so we get the equation 1 by omega C4 R4. So if we calculate this Q value, if we calculate the bottom L1 equal to, we get R1 R2 R3 is C4 R2 R3 C4 by here. So we can write R1 equal to if we calculate here L1 equal to, we get R2 R3 C4 by 1 plus 1 by Q square. So Q is become, if 10 greater than 10, so it is 1 by 100, so it will be neglected. So L1 equal to R2 R3 by C4, same as we divide the Maxwell inductance capacitance B for the previous case. So the advantage of it is uses for Q greater than 10 and almost simplification, but is the disadvantage for greater less than the value it cannot be used. Then in that case we use Maxwell inductance B for that case.